Okay. Good evening, ma'am, and to all present here. I am Sneha Sagar, a proud member of Civi Forensics, and it is my absolute pleasure to welcome you all in this enlightening webinar titled Blockchain in Digital Forensics: The Future of Evidence Integrity. Before we dive into the today's session, let me ask a moment to introduce our esteemed speaker, someone who truly embodies excellence in the field of forensic science. We are honored to have with us Ms. Abhaya Gupta, Assistant Professor at Pandit Deendayal Upadhyaya Shekhwati University, Sikar, Rajasthan, and a UGC NET 2024 qualifier with specialization in digital and cyber forensics. I invite everyone to be active listeners and participants. Please feel free to drop your questions in the chat box. We will address them during the question and answer sessions. Now, without further ado, let's extend a warm virtual welcome to ma'am. We are truly honored to have you with us today.
Hi, everyone. Thank you so much. Good evening. And thank you so much for the warm introduction and inviting me to your platform and organizing this session basically. So I hope that this session will be quite enlightening for all of you because the topic which we have chosen is the most trending topic right now and understanding it from the core is very important. So the topic for today is blockchain in digital forensics, the future of evidence integrity. So I guess we can start.
Yes, ma'am.
Okay, let me share my screen. Okay, so my screen is visible.
Yes, ma'am.
Yes, ma'am.
Okay. So, so the today's topic is blockchain in digital forensics, the future of evidence integrity. So we learn about blockchain, what is digital forensics, what is blockchain, why is there a need to inculcate blockchain in digital forensics, and how it will help to preserve the evidence integrity. So basically, we'll explore how this technology, which started with cryptocurrencies like blockchain, Ethereum, it is now transforming the way we preserve and verify the digital evidence. So I'll start with a case of 2015. So during a high-profile cybercrime case, the investigators, they came across a USB drive which was full of incriminating files. Now those files were against the suspect. Everyone thought that this was just an open and shut case until the defense walked in and they said that these files were planted. That means these files were kept and not originally present in the USB drive. They claimed that someone tampered with the drive and without the proper metadata or the proof, these files were added and there was no way to refuse this claim. So metadata is the data of the anything you can say, like the document, the picture. So when you will open a photograph of yourself in your gallery itself, and you will see the details. So you will see the timestamps, or you can see the location, and you can see the camera from which it was clicked. So that is the metadata of a particular file. Now think about this. Digital evidence lied. The timestamps could have been altered and the metadata wasn't properly captured. And because there was no trustworthy audit trail, the suspect walked free. So now the big question which arises with us is that how do we prove the evidence integrity when the evidence itself is digital? So evidence itself is digital means that it can be easily tempered, edited, manipulated, like which we do in our regular life. We edit a document in just a few seconds. So that is how. So this is where blockchain comes in, not as a buzzword or not as a fuss, but as a new way to make the digital evidence trustworthy again. So I have a question for you, all of you guys, like how many of you have ever deleted or edited a file without leaving a trace? Any one of you? No, you can't. You can't edit or delete a file without leaving a trace. For example, if you delete a file, so that file will be in the recycle bin. Or even if it not, even after the 30 days, there will be traces of that particular file, even if you edit it, because in the Word document also you can see the particular date it was edited, like the last edited. So you can never edit or delete a document without a trace. So now let's understand, you'll see how it happens. And now let's understand what is digital forensics first. So digital forensics, it is the branch of the forensic science, which deals with identification. That means identification of the relevant digital evidences. Acquisition, that means the collection, preservation, examination, and presentation of the particular digital evidence in code. Now this branch, this digital forensic branch, it relies on the four main key principles. First is the integrity. So integrity says that the evidence should remain completely untouched from the moment it is collected. That means it should not be tampered, it should not be manipulated. Second is authenticity. So authenticity said that we must be able to prove that the evidence is genuine and not manipulated or replaced. For example, if we have found a mobile phone, so we should be able to prove, yes, that particular mobile phone was present on the crime scene and we have not planted it itself. Next is chain of custody. So chain of custody, as you all know, is the most basic principle of the forensic science, because it consists of the sequential documentation of every person who has even touched the evidence, like the signatures or all the details of the person who have touched the evidence from collection till the analysis. And fourth is reproducibility. So reproducibility, I'll give an example. Say an investigator, one investigator, he used a technique and followed the particular steps and got XYZ results. And if the another examiner, if he used the same technique and followed the same step, should also get XYZ results. So this is reproducibility. That if another expert follows the same steps, they should reach the same conclusion. Now the problem is digital evidence, unlike the physical one, it is fragile, that you can copy, paste, delete it, rename it, or edit it in seconds. So we need a system that locks the truth the moment it is recorded. My voice is breaking. Can anyone answer it? Like, am I not audible properly?
You are audible, ma'am.
Okay,
For
okay.
me, it's
Thank
voice
you.
is voice, ma'am.
Sorry. Okay, thank you. Okay, so we need a system that locks the truth the moment it is recorded. That is where blockchain fits in. So now, what is blockchain? So let's make blockchain super simple for you. So think of it as a digital notebook that is not owned by any single person. Instead, it is shared and copied across even hundreds or thousands of computers, which are called nodes in blockchain. So blockchain, it is made up of blocks. Now, every time a transaction happens, anything, something happens, like a transaction, even a record or a hash, it is written into a block. Now that each block, it is time stamped. That is, we know where it has exactly happened and at what time. Next, it is linked to the block before it through a something called cryptographic hash. I'll explain you what is hashing. So it is done through cryptographic hash. And once added, it becomes immutable. Immutable, that means no one can change it or delete it. So now there is no single server, no central authority here. Everyone in the network has the right to verify the truth. Like one computer, two computers, three computers, they all verify the truth together. Even if one copy doesn't match, the system rejects it. And that's why we call the blockchain a decentralized truth. It is not a centralized truth, it is decentralized truth. Now, why is there a need to inculcate blockchain in forensic science? Why we are not studying it separately? Or why is there a thought of even inculcating the blockchain into forensics? So the answer lies in both the fields, because both of them are trying to maintain a trust or achieve a trust without tampering it. So this is because, like, traditionally we used to rely on people or institutions for maintaining the trust. Like we used to say that yes, he said that he will maintain the log and he will not tamper it. But now we have replaced blockchain with people, and because of first transparent auditing, every transaction, each and every transaction in blockchain, it is traceable. That means you can see who did it, when did it, why did it. Next is trust without intermediaries. We don't need any intermediates. We don't need any people. We just need the blockchain and our data. Third is tamper-proof evidence tracking. Once recorded, the data cannot be changed, cannot be manipulated, cannot be edited. And fourth is immutability. No one can alter the past records without breaking the entire chain. If you even change a single byte, the entire block hash is changed and your blockchain will be disrupted. So this means that the investigators, courts, and even defense lawyers, they can verify the same truth independently. No more like he said or she said. The blockchain logs, it becomes the ultimate witness in the court. So now let's understand. We have seen like what is blockchain and the basics of blockchain and basics of digital forensics. Now let's deep dive into the blockchain and look under the hood. What is actually the technical core of the blockchain? So first, let's understand the architecture of blockchain, how blockchain is made. So first is each block, the blockchain is made up of blocks, and each block, it consists of a header and a transaction data. The header, it consists of a timestamp, a reference hash value, which is linked to the previous block, and a nonce. So nonce, it is a random number which is used during block validation. Second is the transaction data. So it is not the actual data which we want to store. Like if I retrieve a file from the laptop, so this is not the actual file which we are storing in the blockchain. We'll be storing its hash value, its case ID, so that we can get a reference, yes, that it was the particular case. So it stores what actually is being recorded, like the hash value of the digital evidence, the case ID, and the log of who accessed it. Now, every block in the blockchain, it is cryptographically linked to the previous one. So if you change even a single block, a single byte in a block, the hash breaks and the entire chain collapses. Now the best part is that this ledger means record. So this ledger, it is replicated across multiple nodes. Like I have shown you, there is no central authority. Every other thing is linked. So this is how it is replicated across multiple nodes. Even if one computer is hacked or like failed, hundreds of others, they hold the correct version. So the truth in this case, it cannot be erased. Now I'll show you what is hashing. Like I'm again and again saying that the one block, it is linked to the previous block through hashing, through cryptographic hash. But what is hashing? And honestly, I'll tell you, this hashing, it is one of my favorite concepts because it is like so simple, but it is so genius method to like preserve our evidence and integrity. So I'll tell you what is hashing first. So when we hash a file, anything, we can hash even a document, we can hash even a photograph, a video, anything. So when we hash a file, we are converting that particular file into a unique code, which is its unique digital fingerprint. Now take a document, hash it once, you'll get a long alphanumeric code like consisting of alphabets and numbers. And now change one letter in that file and hash it again. So you will see a completely different code. That is why in forensics, we are using the hash value to prove the integrity. So like if the hash before and after matches, the evidence hasn't changed. It is proven that our evidence is integrated. Now the blockchain uses the same principle of hashing. Every block, it has a hash. So if someone tampers with one, like it mismatches instantly and exposes the cheat. Like I have shown you, this is some text and we use the hash function and this is the hash value. I'll even show you a demonstration first. Okay, so these are the common hash algorithms like SHA-256, MD5, and SHA-3. So SHA-256, it is very strong and secure, and it is used in most of the cryptocurrencies like Bitcoin and even in the forensics. Next is MD5. So MD5, it is less secure and older version. And SHA-3, it is the most latest standards which is being used. So let me share my screen, entire screen to you. Okay, so this is the command prompt which is present in all the Windows system. You can also do it side by side with me. So there's a command cert util space hash file space. Now I have kept my file on the desktop. I'll simply drag and drop it here. I've done nothing. I have just simply drag and dropped it, and I give a space and I write SHA-256. This is the algorithm which we are using. I'll press enter. Just a second. Cert util hash file. Drag and drop the file, and I have written SHA-256. I think I'm not able to do this because I'm presenting my screen. Yeah, got it. This is the hash value. I have done the same thing. I have given the command cert util dash hash file. I have simply drag and dropped my file, and I have written the algorithm SHA-256. This is the hash value of this particular file. So you can see it has just converted my file into an alphanumeric, and it is of 64 characters. So we can also use other algorithms, like I'll show you. Cert util space hash file. I have dragged and dropped my file, and I have given the command MD5. Like I told you, SHA-256, MD5, and SHA-3. These are the basic algorithms which we use. And now I'm using MD5. I've pressed enter, and this is the hash value which we have got from MD5. So as you can see, from SHA-256, we got a 64 length character, alphanumeric string. And from MD5, we got a 32 length string. So this is how it is done. This is hashing. So simple yet so genius method. Okay, let me share it again. Okay, so I hope you all have understood hashing at least very perfectly. All the algorithms and how we can use this. So now that we know how each block is created and hashed, let's now see the whole network, how it decides what it is true. So in blockchain, as I told you, there is no central authority, no admin, no single database controller. So before any new block gets added, all the nodes on the network, all the nodes, I'm saying like all the computers on the network, they must agree that the data is valid, that a particular, like I showed you the specimen file. So the specimen file has this hash value. They must agree to this data. This process is known as consensus. So this can be done by three mechanisms: proof of work, proof of stake, and proof of authority. So what is first proof of work? So proof of work, it is the mechanism which is used by most of the cryptocurrencies like the Bitcoin. It says, it asks the nodes or the computers to solve a tough mathematical problem. And the node who solves the tough mathematical problem first gets to verify the data. But now why they're doing this? Because they get paid for this. The one who verifies it get paid for this. There are miners, there are validators who do this. So first is proof of work. They have to solve a tough mathematical problem, and the one who solves it fast and efficiently gets to verify the blocks. Next is proof of stake. So proof of stake is used by the recent cryptocurrency, which is Ethereum 2.0. So instead of solving the puzzle of solving a tough mathematical problem, here the validators, they stake their tokens to earn the right to verify the data. The one who like stakes the most gets to verify the data. This is faster and more eco-friendly method. Next, third is proof of authority. So it is like perfect for forensic or law enforcement use, because here only trusted participants like the certified investigators or the labs, they validate the data. Because like in forensics, as you know, we don't need a global competition here. We just need the verified trust that yes, actually the data is correct and it is done by the verified users, not the global competition. So consensus mechanism is all good. Next, we'll understand immutability and verification. So how actually blockchain makes the data immutable and verified. We'll understand the steps. Immutable, that means it is not changed, it is not manipulated, it is not altered. So first step is transaction initiation. Any user. So first, a transaction is initiated by the user. Like I did a transaction. This is the first step. Second is hashing. The transaction, it is hashed to ensure the integrity. Side by side, the moment I transacted anything, I hash it so as to maintain its integrity and to verify it. Third step is validation. So like I told you, the consensus mechanism. So the networks, they participate and they validate the transaction, now adding to the chain. So once the data is verified by the nodes and they have said that yes, the data is correct and you can add it to the blockchain. So that particular block is now added to the blockchain. The last step is replication. So this updated blockchain, it is now replicated across hundreds of thousands of computers, because I told you that there is no central authority, no central admin. There are all hundreds, all of them, they have the right to edit it, change it, and all of them have the rights. So that is why a particular transaction, a particular block is now replicated across hundreds or thousands of nodes in a particular network. Now let's link this step of blockchain with the forensic science. How we can use it in the forensic science. So we start by collecting the evidence. Say we have collected a USB image, because we do not analyze the image directly, right? We do not analyze the evidences directly. We first image the device. So we have taken a USB image or a network log, and and we have calculated its hash value using SHA-256. So now the metadata creation. Second step is metadata creation. We attach the essential context like the case ID, the date, the investigator ID, and the location. So like it is traceable and auditable. Third step is hash recording. The hash value, which we have calculated along with the metadata, it is submitted to the blockchain. Now, important is that the data, like I told you, the data is not itself stored. If I extract a file from the laptop, I do not save that file in the blockchain. The hash value of that particular file, it will be stored in the blockchain. So only the hash and the identifiers, they are done so that to keep it lightweight and secure, because blockchain cannot secure like so much heavy data. In forensics, we even image the whole laptop, so we cannot do that. So fourth step is consensus validation. Now the nodes on the blockchain, they verify the new entry to ensure that it is legitimate and it is untempered. And the last step is verification. So like later during the analysis or in the code, you can rehash the same evidence and match it with the blockchain hash. A perfect match, it proves that the evidence has not been altered. And even if a single hash value changes, entire blockchain disrupts, and we can see that yes, the particular file was deleted, manipulated, anything. So and the providing an unbroken chain of custody. This was the forensic data flow. Now we'll see. Now we have seen how a block is created, how we can use this in the forensic science as well. Now in future, if you have to create like any software or any application related to the blockchain, so these are all the architecture. Architecture, that means the layers or the components of like the forensic systems. These are designed to work together using the blockchain technology. So this is what you have to follow if you want to work further in the blockchain, and you have to create like a platform or an application or any solution related to blockchain. This is what the architecture of the blockchain based forensic frameworks look like. So first layer is the acquisition layer. So what is the acquisition layer? Acquisition, that means the collection. So here is where the investigators, they collect the actual evidence and the metadata. They immediately generate a hash and the timestamp. Hashing is the most important thing which we do in the forensic science. So do not forget to calculate the hash value of the file which you have collected, and immediately generate a hash and a timestamp. And that will be a starting point for the integrity. Then instead of uploading the file itself, the hash is sent to the blockchain. I'm repeating it again and again, that the particular file, it is not sent to the blockchain. Only the hash value and the attached things of the metadata, like the case ID, the investigator name, it is sent to the blockchain, not the entire data. Next is the blockchain layer. So this is the core ledger. This is the core record that stores the hashes and the access logs. It has everything, the hash value, the case ID, the investigator ID, everything. This is the layer which stores everything. Then is the access control layer. So this is where the smart contracts come in. Smart contracts, these are the digital records which consists of in written everything, like who has the access to what, which people have the access to view and which people have the access to verify. So it is automatically recorded. Smart contracts are also the main component of the blockchain, and everyone should have the knowledge. They should read the smart contracts first, like if they have actually the authority to change it or just view it. Next, finally comes the application layer. So application layer is what the users see, like we see. If we want to use any problem or any solution related to the blockchain, if we are using any platform related to the blockchain, so we only see the application layer. It is a clean dashboard which is used to verify the evidence, check the integrity, or like review the entire chain of custody in real time. So for example, I'm an investigator and I go to the court and the judge asks me that I want to see the hash value of this particular file. Now I open the particular platform which I want to use and I'll see the application layer only. I put my case, I put the metadata, I put the case ID, the investigator's name, and I get the hash value. So this is what only the users can see, the application layer. And all other are the backend things, and application layer is the front end thing. As I guess you all know the backend and the front end in the engineering. Backend is like what goes on the backside. We can't see it. And the application, the front end is what we can see, what users can see. The UI UX part thing is the front end. Now, approaching towards the end, we'll see some case studies, or let's take some real examples of the blockchain. You might all be confused, like how this actually works, how is blockchain used, how, even if I have told you how to calculate the hash value, but where to put it, how to verify it. So these are the examples which I'm telling you. First is the Chainify. So Chainify, it is a platform which is built to help the investigators prove that the digital evidence has not been changed, even the years later. So how it works? First is that when a piece of evidence, say anything, any log, any photo, any video, it is collected, the Chainify immediately collects a hash. It creates a hash value of that particular file. Hash value, as you all know, it is unique to each and every file. There is no hash value which is similar. And it adds a timestamp. That is when this hash value was created, who created it. Then this combination is stored on the blockchain. And because the blockchain is immutable, this record cannot be altered. And later, if someone questions it, or like investigators can simply compare the file's hash with what's stored on the blockchain. Now, if they match 100%, even if a single numeric is not changed, then it is authentic. Then our evidence is authentic and it has not been changed. So Chainify only focuses on providing the real-time integrity proof, like without relying on any central authority. Blockchain is a decentralized chain. It is not a centralized chain. So only a central authority, not a central authority. All the networks, all the nodes, in the network, they have the right to verify it and no one can change it. Now, the second example, one more very interesting, is block audit. So block audit, it was a system. It is designed to bring the transparency into how digital evidence is handled inside the forensic labs. So it was only designed just for the forensic labs, because we need specific things which other platforms or which other labs or like other private companies are not using, because forensics is what, like maintaining the integrity, not exposing our data. So this is why block audit was created, mostly because of the forensic labs. And normally we rely on like manual logs, who collected the evidence, who analyzed it, who verified the report. We make a register. In some places of India, there are still like manual logs created, but those logs, they can be easily altered or lost. But the blockchain changes it. Every single piece of evidence, every single action, from like the extraction to analysis to verification, it is recorded on the blockchain. It is maintained side by side. Instead of the manual logs, they are maintaining it on block audit. This means that once a step is logged, no one can secretly change it or delete it. This is what block audit does to us. Now, the research gaps and the future directions. So, what are the things which have not been worked upon, and what are the things which we can work on in future? What are the things? So, first is scalable evidence storage and retrieval system. So, as I told you, that the original data which we have restored is never stored on the blockchain because it is too heavy for the blockchain to store it. So right now, storing the actual evidence on chain, it is impractical because blockchain is not designed for heavy data. We need better hybrid systems that can handle the large evidence files efficiently. Second is dynamic access control and role revocation. So role revocation is taking back the rule. So let's take an example that a case is not solved by any particular agency and it is passed on to higher agency, anything like CBI. So the investigators of the previous agency, they also have the right to still access the data and they can change it or like manipulate it or they can see it. Not manipulate it, but they can exactly see it. So we need some smarter permission systems that adapt as cases evolve so that to take back the roles from them, to take back the access from them so that they cannot view it. Next is lightweight consensus mechanism. Like most of the blockchains, I told you, they work on proof of work. So proof of work, it requires the nodes or the computers to solve the heavy mathematical problems. Now these heavy mathematical problems, they require manual power, like the people have to solve it, or also the huge electricity. Now we need for this, for forensic users, we need lighter and faster methods to ensure the trust. Then comes the standardization of evidence metadata. So every system defines the evidence metadata differently. Like without any common standards, it is hard to share or compare the forensic data across agencies. Metadata do not have any proper format. It can be stored in any format by any investigating agency. And sharing that particular format to other investigating agency is very difficult. So we need a standardized metadata. Next is privacy preserving the blockchain models. So we want transparency, but like not at the cost of exposing our sensitive information. What is forensics? Forensics is keeping everything in safe, not exposing it and not giving out our evidence. But what is blockchain? Blockchain is about transparency. So balancing both of them, it is a big research challenge and we have to work upon this. And finally comes the integration with the digital forensic tools. There are no innovations, no future directions related to blockchains being integrated into the standardized forensic tools like FTK, autopsy, NCase, which we use daily in our forensic labs. And we need this because so that the investigators, they can use the blockchain without leaving their workflow. They do not have to go to another platforms like I told you, Chainify or block audits. We do not have to go to other platforms. We can integrate them in our daily use, autopsy, FTK, NCase, so that it will be useful for the users as well and forensic investigators, the courts, the judges, everyone. So I hope you got like the overall view of what is blockchain, what is digital forensics, how we work on this. I'm open to questions now, whoever wants to ask this.
Anyone wants to ask any question? I guess there is no question, ma'am. So, okay. So as we come to the close of today's event, let's express our sincere gratitude, a heartfelt thank you to our speaker for sharing her valuable time, experience, and knowledge with us. Your insights have truly enriched and inspired us, ma'am. A big thank you to all our participants for your exhaustion and engagement. Your presence makes session like this so meaningful. Once again, thank you everyone for joining us. Stay connected, stay curious, and stay inspired.
Thank you guys. Thank you for inviting me.